So in this video, we're going to talk about infinite limits and limits at infinity. And we're really going to dive a little bit deeper into that idea of what a vertical asymptote is and what a horizontal asymptote is and what is in behavior. And it turns out all of that stuff that you learned from pre-cal algebra is really built on this idea of a limit as we get close to a particular x value. Do we have some kind of strange behavior? And I'm going to call that unbounded behavior. And what that means is as we get close to that x value, are the y values getting super big or are they getting super small? And that's your idea behind a vertical asymptote. Do we have values that are getting super big or super small? And we say that if that happens, we're increasing without bound or we're decreasing without bound. And a good example of this would be looking at one of those parent functions from 171, like y equals 1 over x. We know that this graph looks like this. There's a piece of it in the first quadrant and a piece of it down here in the third quadrant. And we already know this guy has a vertical asymptote at 0. Okay. But the reason that happens, why it's called a vertical asymptote, goes back to this definition that's built on limits. So let's dive into that. We say the vertical line x equals a is a vertical asymptote for the graph y equals f of x if f of x approaches infinity or negative infinity as x approaches this value a from the right or from the left. So what's happening is we have unbounded behavior. So if we go back to that parent function, y equals 1 over x, and look at what happens as x gets closer to 0, I'm going to take the limit as x approaches 0 from the left and from the right. And I'm going to just go to my calculator here. So here's my calculator. I'm going to graph the function y equals 1 over x. And I'm going to use my table. Now, I do have my table set up so I can type in any x value. To do that, you're going to hit second and window and set your independent variable to ask. So let's look at what happens as we approach 0 from the left. So if you think about 0 from the left, and I'm going to go back to my notes here. Sorry for the rotations. So as I approach 0 from the left, I want to get really close to 0. So let's start by looking at what happens at -1. And then we're just going to move closer and closer to 0. Maybe look at -1/2. And then maybe -0.1, and then -0.01, and so on. And we're asking, what's happening to the y values? So we've got the function y equals 1 over x. I'm going to my table. At -1, that y value is -1. At -1/2, I'm at -2. And now I'm really going to get close to 0 from the left. Let's look at -0.1. And then -0.01, and then -0.001. So you can see as we get closer to that value of 0 from that left-hand side, those y values are getting super small. I'm going to go in just a little bit closer here, and I'm just going to use a whole bunch of zeros there. So as I get closer to 0 from the left, those y values are heading down towards negative infinity. So we would say the limit as x approaches 0 from the left of 1 over x is heading towards negative infinity. Now, just a side note here, usually when we take a limit, we want a specific value, like a specific number like 1 or 2 or something like that. Technically what's going on is this limit does not exist, but it doesn't exist in a particular direction, and that's that negative infinity direction. So if we can identify the direction it doesn't exist in, then we can denote that by saying it's going to infinity or it's going to negative infinity. And what that means is that we have something special going on there. There could be some kind of asymptote. And in this case, we're showing a vertical asymptote. Now, if we were to look at that graph, here's my sketch of that graph. As x comes in from the left, you can see that all of those y values are getting smaller and smaller, and they are heading down towards negative infinity. So we could do the same kind of thing with 1 over x approaching from that right-hand side. So if I come in from the right, looking at that number line up here at the top of the page, I'm looking at what happens as I zoom in on that value, x equals 0 from the right. So I could look at what happens when x is 1, x is 1/2, and I'm really going to zoom in by looking at 0.1, then 0.01, and so on. So if I go back to my picture here, my calculator, I'm just going to delete all of these. So at positive 1, my y value is 1. At positive 1/2, my y value is 2. And then I'm really going to start zooming in. I'm at 0.1, 0.01, and you can see the closer I get to 0 from that right-hand side, the bigger those values for y are getting. And they're getting exponentially larger there. So we would say this is heading towards positive infinity. Now, once again, the limit doesn't exist, but it doesn't exist in a particular direction, and that's what that positive infinity and that negative infinity means.